Plutonium-238. What is plutonium? Plutonium was discovered in 1941. It is a chemical element with a symbol Pu. And in the periodic table of elements, it is located in the 94th place, which means it has 94 protons. It has several isotopes. The isotopes of an element differentiate from each other by their number of neutrons in the nucleus. The most important isotope of plutonium is plutonium-238, with a half-life of 87.7 years. The half-life is the time it takes for half of the atomic nuclei to transform. Plutonium is not found in nature. We cannot mine it as iron ore or any other ore. It is produced from uranium, which we obtain from uranium ore. When uranium-238 is bombarded with deuterium nuclei, neptunium-238 and two neutrons are produced.
Neptunium-238 has a half-life of only 2 days and decays to plutonium-238 by electron radiation. Initially, plutonium-238 was produced at Savannah River site in South Carolina, USA, which was built in 1950. It has been produced here for about 300 kilograms in almost 30 years. However, in 1988, the plant closed and the world's plutonium-238 reserves rapidly dwindled.
Scientists from Oak Ridge Laboratories have found a way to automate part of the plutonium production process. Neptunium-237 is mixed with aluminium and the resulting mixture is filled into pellets under high pressure. They are stored in a reactor where they are irradiated and plutonium-238 is formed from neptunium-237. Thanks to automation, there is a threefold increase in production. The total annual production will increase from 50 to 400 grams, and in 2025 it should reach up to 1.5 kilograms. Plutonium-238 is not used for the production of nuclear bombs, nor as a fuel for nuclear reactors. It is a powerful alpha emitter and is therefore used primarily as a source of energy in radioisotope thermoelectric generators X-rays. During its spontaneous decomposition, thermal energy is released and it is converted into electrical energy by means of thermocouples.
Now, let's talk about the latest mission where plutonium-238 was used, Mars 2020. But first, we must answer the question, why do we use plutonium in the first place? Why not solar panels? I mean, solar panels have some advantages over reactors. The very first, which is pretty obvious, is money. Plus, solar panels also have theoretically longer lifespan of around 25 to 30 years, while reactor has an average lifespan of around 15 years.
Okay, so solar panels are cheaper and have a longer lifespan. So why are we even discussing this?
I'm glad you asked. Solar panels are great for most of the missions, but they are definitely not a good option for Perseverance. If you've ever been on Mars, you should have noticed that there is quite a lot of dust, and solar panels and dust are not a very good friends. NASA even used solar panels in their early rovers called Spirit and Opportunity, but they turned out to be ineffective. So on their next rover, Curiosity, they decided to put their MMRTG, or Multi-Mission Radioisotope Thermoelectric Generator.